I'm going to do some of these for you. So more practice on horizontal asymptotes. It says determine the end behavior. So what's happening on the end of the graph or the horizontal asymptotes of the following functions by finding the limit as you go to infinity and negative infinity. So we're going to do both directions. So that's very important. We want to know what's happening on both sides of the graph because, like I said, some will have two horizontal asymptotes. All right, so then we're going to do a rough sketch of the ends only because it makes it easier for me to grade. So you're going to be nice to your teacher. You like me in a happy mood when we're grading, right? Yeah. All right, so this first one, so we have f of x equals 3x squared minus 7x over x minus 8. So the first thing to notice is that there is no horizontal asymptote. And we know that because the degree on the top is bigger than the degree on the bottom. So it's like having 3x squared over a 0x squared, right? That is undefined. So that's the first thing we notice. So when there is no horizontal asymptote, that means that the ends of the graph, like as I go to infinity, I can go up or down. And as I go to negative infinity, I can go up or down. We want to know what's happening. Okay, so we're going to say the limit as x goes to infinity of f of x. And we're going to use an approximation for f of x. So your function is approximated by only the largest degrees. We don't worry about anything else, only the largest degree in the numerator and the largest degree in the denominator. So we're going to use 3x squared and we're going to use x, which ends up reducing down to 3x. So if I plugged in a very large positive number into my simplified version, don't I get a very large positive number? Did you guys see that? So the limit as I go to infinity is infinity. If I plug in a very large negative number, do I get a positive or a negative? A negative number, right? So that means on the ends of my graph, as I go to infinity, I'm going up. As my x value goes to negative infinity, I go down. That's all I want you to draw, just the ends of the graph. Does that make sense? And I want you to write it this way too, obviously. So on the next one, is there a horizontal asymptote? Yes, the horizontal asymptote is y equals 0. So for this one, if you were using that approximation for your function, you had 2t to the, I don't know why I did f of x and then wrote t's, f of t, my 2t to the second over 2t to the fourth, not 2t to the fourth, just t to the fourth, ends up going down to 2 over t squared. It doesn't matter if you plug in a positive number or a negative number, so it can be a big positive or a big negative. They both give you 0. They're both giving you that same horizontal asymptote. Do you guys get it? It's 0, yep. So it's not one where there are like two horizontal asymptotes or anything. So I'm going to skip 3. So let's look at some other weird ones. Yeah, so I would still like maybe on the ends just do like just so it's easy for me to grade, like do something like that so I know it's going towards 0. It's hard to do it exactly on the axis, isn't it? All right, so 4 and 5 are similar as well. Yeah, Evan?
Back on number 2, why is the horizontal asymptote equals 0?
Because if you look at your horizontal asymptote trick, look for the largest degree. Your largest degree is not t squared, it's actually t to the fourth. So you have 0t to the fourth over 2t to the fourth. So it's 0 over 2. Do you remember that shortcut? Largest degree on the top and the bottom. So for instance, oops, I erased too much. So like on the next one, your largest degree is x to the 6th, so you'd have 0 x to the 6th over 1 x to the 6th. You don't have any x to the 6th on top. You do have an x to the 6th on the bottom. So that would be 0 as well. Remember the shortcut method? All right, so same idea for 4 and 5. So you just want to decide, is the degree larger on top? Is it larger on bottom? Do I have a horizontal asymptote? What is it? What happens is I plug in a positive and a negative. So like on number 5, if you approximate this function, it's negative t to the 5th over t to the 4th. So you end up getting negative t, right? You're going to use that as you take the limit as t goes to infinity and also negative infinity. Okay. All right, I'm skipping through. All right, let's look at the weird ones. Square roots. So we've done quite a few with square roots. So we're approximating the function. We're not worrying about the 1 and the 2. We're just worrying about our largest degree on the top, largest on the bottom. So if I take the square root of 4x squared, I get 2 absolute value of x, right? Because we know the square root of x squared is equal to the absolute value of x. On the bottom, we have 5x. So now we're thinking, well, what happens as I plug in a big positive number and a big negative number? Oops, negative infinity. All right, what do we get for the positive one? Not 0. 2 over 5, right? So if I even think about plugging in 100. If you plug in 100, you get 2, absolute value of 100. Oops, not 0. Absolute value of 100 over 5 times 100, right? Absolute value of 100 and 100 just cancel. You get 2/5. But if you plug in a negative 100, the top becomes positive because the absolute value of the bottom is negative, so you get negative 2/5. Okay. So if I was doing a rough sketch of this on the ends, I would put something like 2/5, dot, dot, dot. So you're going along there, negative 2/5, going along there. I don't know exactly where it is, if it's above or below or whatever. I'm just worried about the ends. All right, so same idea for 7. How about number 8? 8's a little bit different than what we've done. What's different about it? Yeah, it's got a cube root, right? So yeah, if we do the cube root of 8x cubed, I'm going to get a 2. Do I need absolute values? No, you don't, because x could be positive or it could be negative. If I plug in a really large negative number, it's going to be negative. All right, and then the bottom is still 5x, so use that for that one. And then number 9 is definitely the hardest. So I have 1 minus e to the x, and then I have 1 plus 2 e to the x. Okay, for this one, I just want you to think about positive and negative 100. Sometimes that kind of helps you logic through these problems. So if I had 1 plus e to the 100 over 1 plus 2 e to the 100, the 1 plus stuff is insignificant. E to the 100 is ginormous. 1 plus, still ginormous, it's just a smidge bigger, right? So we're not worrying about the plus 1. So we're going to approximate this by e to the 100 over 2e to the 100. What does that work out to be? Oh, it's fine. Either way. Same thing. I guess it is a negative though, isn't it? So yeah, maybe I should give Charles a bonus point, shouldn't I? All right, so what is it approximated into? Yeah, it's negative 1 over 2, right? So as you plug in even bigger numbers, 1,000, 1 million, 1 trillion, right? That's going to get even closer to the negative 1/2. Okay, do you guys understand what I'm saying? So that means that our limit as x goes to infinity for our g of x function, that's negative 1/2. But let's talk about a negative 100. So if I plug in a negative 100, I have 1 minus e to the negative 100 over 1 plus 2e to the negative 100. And I'm going to be really careful. I'm not getting rid of those 1s this time. Because e to the negative 100, what is it very, very close to? 0, right? Because this is what we're thinking. It's 1 minus 1 over e to the 100. And 1 plus 2 times 1 over e to the 100. These are the parts that are insignificant now. This is going to 0, and this is going to 0 as we plug in values that are even bigger than 100. 1,000, 1 million, 1 trillion. Do you see what I'm saying? So what is this one close to? Not negative. It's close to 1, right? So that's going to be the limit for that one. So the limit as x goes to negative infinity of g of x is equal to negative 1. Now could you do a table on your calculator? Sure. Oh, dang it. You got me. Negative 1. It's 1. Darn you, Olivia, you said -1 and I had that in my head. That's fine. All right, so we want to go and draw a little rough sketch. So as I go to infinity, I'm getting close to 1/2, -1/2. And as I go towards negative infinity, I'm getting closer to 1. Oh, man. So somewhere around here and then somewhere around here. So there's something weird going on there. All right, so like I said, you could graph these. You could do your table of values on your graphing calculator, but I want you to be able to kind of logic through what's happening and say, okay, this is really big on top. This is really small on bottom. So it's going to infinity, right? Yeah.
You put -1 again on
Did I? I crossed it out. I didn't do a very good cross out, but yeah. All right, was that the last one? There is one more. All right, so g of t equals, this is kind of a tricky one. All right, so we are approximating it by the square root of t all over t, which is really like if you had t to the 1/2 over t, which degree is larger? It's on the bottom, right? It's like having a 1 over t to the 1/2. That's what we're using as our approximation. So as I plug in a really big positive number, what do you think we go to? Yep, that one's 0. All right, trick question. If you can get this, I'll be super impressed. A big negative number. It is no solution. Isabeth, how did you get no solution? She said it so quietly.
So, like, if you put negative infinity into the square root, it doesn't.
Yeah, if you plug in a really big negative number, even like -100, right, into that square root, do you get a number out? Nope, you get the square root of a negative. Okay, so you have to consider things like that as well. So this one does not exist.
So for the graph, did you just put the infinity?
Yeah, you would just do the 0, and then this side has nothing. There's nothing on the left side. All right, think you guys can handle the rest of those problems for homework? Yeah, Ariana?
On the front page, number 4, if there's a horizontal asymptote, would that affect the end behavior?
The horizontal asymptote is the end behavior then, right? It's saying what do you get closer to as you go really far on the right side and far on the left side? You're getting closer to the horizontal asymptote. Yeah, Caroline?
And then for 5, why isn't it 0? Because they're, like, I thought it would be like negative t bit over 0.
This is no horizontal asymptote.
Oh, okay.
But when you're using, like if you want to figure out if it goes up or down, you're using the simplified function.
Okay, so
Okay.
then what are the ends?
So you want to know if they go to infinity or negative infinity, so think about it. So you're going to use that negative t to help you. All right, so that's it there.